Welcome back. In the last video, we saw the power of the torch.nn.linear layer and backpropagation and gradient descent. And we got some pretty darn good predictions out of our model. So that's very exciting. Congratulations. You've now trained 2 machine learning models. Woohoo! But it's not over yet. We've got to save and load our trained model. So I issued you the challenge in the last video to try and save and load the model yourself. I hope you gave that a go, but we're going to do that together in this video. So we're going to start by importing path because we would like a file path to save our model to. And the first step we're going to do is create models directory. We don't have to recreate this because I believe we already have one, but I'm going to put the code here just for completeness. And this is just so if you didn't have a models directory, this would create one. So model path is going to go to path models, and then we'd like to model path.makeDir. We're going to call makeDir for make directory. We'll set parents equal to true, and if it exists, okay, that'll also be true, so we won't get an error. Oh my gosh, Google Colab, I didn't want that. We won't get an error if it already exists. And 2, we're going to create a model save path. So if you recall that PyTorch objects in general have the extension of what? This is a little pop quiz before we get to the end of this sentence. So this is going to be PyTorch workflow for this module that we're going through. This one here, chapter 01. PyTorch workflow model 1, and they usually have the extension .pt for PyTorch or PTH for PyTorch as well. I like PTH. But just remember, sometimes you might come across slightly different versions of that, PT or PTH. And we're going to create the model save name, or the save path. It's probably a better way to do it. Is going to be model path, and then we can use, because we're using the pathlib module from Python, we can save it under model name. And so if we look at this, what do we get? Model save path. We should get, oh, path is not defined. Oh, too many capitals here, Daniel. The reason why I'm doing these in capitals is because oftentimes hyperparameters such as epochs in machine learning are set as hyperparameters. LR could be learning rate, and then you could have as well model name equals yeah. But that's just a little bit of nomenclature trivia for later on. And model save path, we've done that. Now we're going to save the model state dictionary rather than the whole model. Save the model state dict, which you will find the pros and cons of in where? In the PyTorch documentation for saving and loading a model, which was a little bit of extra curriculum for a previous video. But let's have a look at our model save path. We'll print it out and we'll go torch save. We'll set the object that we're trying to save to equal model1.stateDict, which is going to contain our trained model parameters. We can inspect what's going on in here. StateDict. That'll show us our model parameters. Remember, because we're only using a single linear layer, we only have 2 parameters, but in practice, when you use a model with maybe hundreds of layers or tens of millions of parameters, viewing the StateDict explicitly like we are now might not be too viable of an option, but the principle still remains. A StateDict contains all of a model's trained or associated parameters and what state they're in. And the file path we're going to use is, of course, the model save path, which we've seen here is a POSIX path. Let's save our model. Wonderful, saving model to this file path here. And if we have a look at our folder, we should have 2 saved models now. Beautiful, 2 saved models. This one was from the workflow we did before up here, saving a model in PyTorch, loading a PyTorch model, and now the one we've got, of course, model 1 is the one that we've just saved. Beautiful. So now let's load a model. We're going to do both of these in one video. Load a PyTorch model. You know what? Because we've had a little bit of practice so far and we're going to pick up the pace. So let's go loaded. Let's call it, we'll create a new instance of loaded model 1, which is, of course, our linear regression model v2, which is the version 2 of our linear regression model class, which subclasses what? Subclasses nn.module. So if we go back here, up here to where we created it, so linear regression model v2 uses a linear layer rather than the previous iteration of linear regression model, which we created right up here. If we go up to here, which explicitly defined the parameters and then implemented a linear regression formula in the forward method. The difference between what we've got now is we use PyTorch's pre-built linear layer, and then we call that linear layer in the forward method, which is probably the far more popular way of building PyTorch models, is stacking together pre-built NN layers and then calling them in some way in the forward method. So let's load it in. So we'll create a new instance of linear regression model v2. And now what do? We've created a new instance. I'm just going to get out of this, make some space for us. We want to load the model state dict, the saved model1 state dict, which is the state dict that we just saved beforehand. So we can do this by going loaded model1, calling the load state dict method, and then passing it torch.load, and then the file path of where we saved that PyTorch object before. But the reason why we use the path lib is so that we can just call model save path in here. Wonderful. And then let's check out what's going on. Or actually, we need to put the target model or the loaded model to the device. The reason being is because we're doing all of our computing with device agnostic code. So let's send it to the device. And I think that'll be about it. Let's see if this works. Oh, there we go. Linear regression model v2. In features 1, out features 1, bias equals true. Wonderful. Let's check those parameters, hey? Next, loaded model 1 dot parameters. Are they on the right device? Let's have a look. Beautiful. And let's just check the loaded state dictionary of loaded model 1. Do we have the same values as we had previously? Yes, we do. Okay, so to conclusively make sure what's going on, let's evaluate the loaded model. Evaluate loaded model. Loaded model 1, what do we do for making predictions, or what do we do to evaluate? We call .eval. And then if we're going to make some predictions, we use torch inference mode with torch inference mode. And then let's create loaded model 1 preds equals loaded model 1, and we'll pass it the test data. And now let's check for equality between ypreds, which is our previous model 1 preds that we made up here, ypreds, and we're going to compare them to the fresh loaded model 1 preds. And should they be the same? Yes, they are. Beautiful. And we can see that they're both on the device CUDA. How amazing is that? So I want to give you a big congratulations because you've come such a long way. We've gone through the entire PyTorch workflow, from making data, preparing and loading it, to building a model, all of the steps that come in building a model. There's a whole bunch there. Making predictions, training a model. We spent a lot of time going through the training steps, but trust me, it's worth it because we're going to be using these exact steps all throughout the course. And in fact, you're going to be using these exact steps when you build PyTorch models after this course. And then we looked at how to save a model so we don't lose all our work. We looked at loading a model, and then we put it all together using the exact same problem, but in far less time. And as you'll see later on, we can actually make this even quicker by functionizing some of the code we've already written. But I'm going to save that for later. I'll see you in the next video, where I'm just going to show you where you can find some exercises and all of the extra curriculum I've been talking about throughout this section 01 PyTorch workflow. I'll see you there.